So now we'll take up the next category, so that is the 5 marks category. And here we'll take a quick revision and try to solve some important problems here. So now taking up the question number 1 we have. So here in the 5 marks question category we have, so if A is equal to the matrix as shown, so verify that A into adjoint A is equal to adjoint A into A, and that is equal to A determinant into I. So where I is the identity matrix of the third order. And the questions 2, 3 and 4 we have to solve by the matrix method. So given the equations in the question 2, 3 and 4, we have to solve the given equations, so by using the matrix method. So that is, we have to find out the values of x, y and z. So now taking up the first problem, so that is, we have to verify A into adjoint A equal to adjoint A into A, and that is equal to A determinant or determinant of A into I. So writing down the solution for the first question we have. So given the question A, so now let us find out the adjoint A for this. So in order to find out the adjoint A, so we have to write down the cofactor matrix. So once we write down the cofactor matrix, so then we will be able to identify and find out the adjoint A. So therefore here we have, so A determinant. So let us try to evaluate A determinant. So because we have to show that A determinant into I also we have to evaluate. So that A determinant equal to, so now expanding along the row 1 we have, so 1 into 0 into 1 is 0, and minus of, so minus 1 into 2 is plus 2, and minus 2 into, so leaving out the corresponding row and column elements. So we have 5, 2 and 1 as the elements of the determinant, so that we have, so 2 into, so 5 into 1 is 5, and minus of, so 1 into 2, so that is 5 minus 2, and minus 3 into, so minus 5 minus 0. So therefore on simplifying this we have, so 1 into 2 minus 2 into 3 minus 3 into minus 5, so that is equal to 2 minus 6 plus 15, so that is equal to 11, so which is not equal to 0. So therefore we can say that it is a, so non-singular matrix, and therefore A inverse exists. So now in order to find out the adjoint A, so we can write down the cofactors of this. So cofactors can be written, so either in the matrix itself, or you can find out it separately and then you can include it in the matrix. So but now, so here I have so found out A adjoint A, so as written in the matrix itself. So A, the adjoint A, so this, so as I told you, the cofactor, so that is A11, A12, A13, A21, A22, A23, and A31, A32 and A33. So this can be written like this also. So by deleting the corresponding row and column elements, so with respect to the cofactor numbers, so with respect to the cofactor element numbers, so we can write down this as, so plus of 0, 2 and minus 1, 1. So because the cofactor, so that is 1. So now, so leaving out the corresponding row and column elements, so we are left with 0, 2 and minus 1 and 1. So therefore we can write this as 0, 2 and minus 1, 1 as the, so the value of this determinant, so will be the cofactor value, so that is A11. So similarly we can find out A12, so that is we have minus of A12, so that is we have, so leaving out the corresponding row and column elements, so we are left with 5, 2 and 1 and 1. So therefore we can write 5, 2 and 1 and 1. And coming to the cofactor A13, so cofactor A13 is this element, so this is the element A13. So therefore, so leaving out the corresponding row and column elements, so we are left with 5, 0 and 1, 1 minus 1. So therefore you can write down the the elements of the determinant as 5, 0 and 1 and minus 1. So next, coming to the next one, so that is cofactor of A21. So cofactor of A21, so is here, so this position is A21, so that leaving out the corresponding row and column elements, so you are left with 2, minus 3 and minus 1 and 1 as the elements of the determinant. So you can write this as, so 2, minus 3 and minus 1 and 1, so with a negative sign, and plus, so cofactor of A22, so leaving out the corresponding row and column elements, so you are left with 1, minus 3 and 1 and 1. So therefore we can write this as 1, minus 3 and 1 and 1 as the elements of the determinant, so that after evaluation of this determinant we can find out the cofactor of A22. So then similarly the cofactor A23, so that is minus of, so leave out the corresponding row and column elements, you are left with 1, 2 and 1 and minus 1. So therefore you can write this as 1, 2 and 1 and minus 1 as the elements of the determinant. And then further the cofactor of A31. So cofactor of A31 is this position, so leaving out the corresponding row and column elements, so you are left with 2, minus 3 and 0 and 2 as the elements of the determinant, so that you can write this as, so 2, minus 3 and 0 and 2 as the elements of the determinant. So next the cofactor of A32, so that is we have minus of, so cofactor of A32, so leaving out the corresponding row and column elements, so you are left with 1, minus 3 and 5 and 2. So therefore you can write down the elements as 1, minus 3, 5 and 2 as the elements of the determinant. And then the cofactor of A33, so cofactor of A33, so that is leaving out the corresponding row and the column elements, so you are left with 1, 2 and 5 and 0 as the elements of the determinant, so that you can write 1, 2, 5 and 0 as the elements of the determinant. So now we can evaluate the values of each of these determinants, so which will be the cofactors of this, and then you can find out the transpose of this, so that if you find out the transpose of this, so that will be the adjoint of A. So therefore now evaluating each of the determinant, we have 0 into 1 is 0 and minus 1 into 2 is, so minus 1 into 2 and minus of that, so that will be equal to plus 2, so that like that we can evaluate each value of this determinant and write down its value, so that we have 2, minus 3, minus 5 as the first row element, 1, 4 and 3 as the second row element, and 4, minus 17 and 10 as the third row element. So therefore the transpose of this, so this is the cofactor matrix, so therefore the transpose of that will be the adjoint matrix. So now, so converting the rows into column elements, or rows or column into rows elements, so that we have 2, 1, 4, minus 3, 4, 7, so minus 17 and minus 5, 3 and minus 10 as the adjoint matrix. So because you are converting the column, so that is here in the having 2, 1 and 4 as the column 1, so this is converted to row 1, so that is 2, 1 and 4 in the row 1. So like that similarly we can convert R2 into C2 and R3 into C3. So therefore you get the adjoint matrix. So now we have found out the adjoint A matrix. So now we have to find out A into adjoint A. So A into adjoint A is the matrix multiplication of the matrix A with the adjoint A matrix. So now you can perform the matrix, so multiplication between the A matrix and the adjoint matrix. So by multiplying and adding the corresponding row elements with the corresponding column elements. So therefore we get, so 2 minus 6 plus 15, 1 plus 8 minus 9 and 4 minus 34 plus 30 as the first row elements, and 10 minus 0 minus 10 and 5 plus 0 plus 6 and 20 minus 0 minus 20 as the second row elements, and 2 plus 3 minus 5 and 1 minus 4 plus 3 and 4 plus 17 minus 10 as the third row elements. So this on simplification we have 11 0 0 as the first row element, 0 11 0 as the second row element, and 0 0 11 as the third row element. So call this as the expression number 1. So that is, we have found out A into adjoint A. So next we will find out adjoint A into A. So for this you write, so first you write the adjoint A matrix and then you write down the A matrix. So because this will give you a different solution. So that is, so we can have to write down in this form only. So because you have to write down adjoint A, so in the first place, so then you have to write down the matrix A. So now you perform the matrix multiplication between the adjoint A and the matrix A. So by multiplying the corresponding rows of the adjoint A matrix, so with the corresponding elements of the A matrix. So therefore you get as shown here, so 2 plus 5 plus 4, 4 plus 0 minus 4, and minus 6 plus 2 plus 4 as the first row elements, minus 3 plus 20 minus 17, minus 6 plus 0 plus 17, 9 plus 8 minus 17 as the second row elements, and minus 5 plus 15 minus 10, and minus 10 plus 0 plus 10, and 15 plus 6 minus 10 as the third row elements. So this on simplification we get 11 0 0 as the first row element, 0 11 0 as the second row element, and 0 0 11 as the third row element. So this you call it as the expression number 2. So now we have already evaluated A determinant. So A determinant value is equal to 11, isn't it? So that we have already evaluated. So let us further evaluate and see that the A determinant value is equal to 11. So from this we can show that A determinant into I. So here we can have the value of A determinant is 11 and I is the identity matrix. So that is, we have the matrix 1 0 0, 0 1 0, and 0 0 1. So this is the identity matrix I. So therefore 11 into I will be 11 0 0, 0 11 0, and 0 0 11 as the elements of the A determinant into I. So call this as the equation number 3. So clearly from 1, 2 and 3 we can see that A into adjoint A equal to adjoint A into A. So that is equal to A determinant into I. So hence we have proved the following property. So and this completes the solution. So for the question number 1. So now let us take up the question number 2. So solve by matrix method. So we have to solve the given equations by matrix method. So we have 3x minus y plus 2z equal to 13, 2x plus y minus z equal to 3, and x plus 3y minus 5z equal to minus 8. So now as I told you, so in these type of equations, so we have to take the coefficients of x, y and z as the matrix form. So therefore, so considering the equations 1 and 2 and 3, so let us call this as equation 1, so and then the equation 2 and then the equation 3. So by taking the coefficients of x, y and z of the 3 equations, we can form a matrix A. So therefore the coefficient of x in the equation 1, we have coefficient of x is 3, coefficient of y is minus 1, and the coefficient of z is equal to 2. So therefore the first row elements of the matrix A will be 3, minus 1 and 2. And coming to the second equation, we have the coefficient of x is 2, the coefficient of y is 1, and the coefficient of z is minus 1. So therefore we have 2, 1 and minus 1 as the elements of the second row. So then we have in the equation 3, the coefficient of x is 1, the coefficient of y is 3, and the coefficient of z is minus 5. So therefore 1, 3 and minus 5 are the elements of the third row of the given matrix. So now let us write the matrix A as the coefficients of x, y and z, and the matrix x equal to the variables. So here the variables are x, y and z. So let us write the matrix x as the variables x, y and z, and the matrix B as equal to the constant. So that is 13, 3 and 8. So we have written the given equations in the matrix form. So now we have of the form Ax equal to B. So this equation can be written in the form Ax equal to B, so that we have x equal to A inverse of B. So now we have to find out A inverse. So in order to find out A inverse, so we have to find out A determinant, and then we have to find out the adjoint of A. So first let us try to find out A determinant. So A determinant equal to 3 into, so now you have already solved so many problems in finding out the A determinant values. So similarly you can find out the A determinant of the matrix A. So that is we have 3 into, so 1 into minus 5, and so minus of 3 into minus 1. So like that we can find out A determinant as 3 into minus 5 plus 3 minus of minus 1 into, so minus 10 plus 1 plus 2 into 6 minus 1, and that will be equal to 3 into minus 2 plus 1 into minus 9 plus 2 into 5. So this is equal to minus 6 minus 9 plus 10, or this will be equal to minus 5, so which is not equal to 0. So therefore A is a non-singular matrix, and therefore A inverse exists. And further we have to find out adjoint A. So adjoint A, so write down the cofactors of the given elements of the matrix A, and transpose of that will give you the adjoint A matrix. So here the transpose of this. So in order to write down the transpose of this, so that we can write down the cofactor matrix. So as I explained you earlier in the previous question, so write down the cofactors of this, so that the adjoint A matrix can be written as shown here. So therefore we can write down the cofactors of A11. So since in the matrix A we have the elements as shown here, so therefore we can find out the cofactors of each of the elements of the matrix A. So that is A11, A12, A13, A21, A22 and A23, and A31, A32 and A33. So therefore the cofactors can be written in a much simplified way in this form. So that is we have 1 minus 1, 3 and minus 5, and then we have minus of, so 2 minus 1 and 1 minus 5. So this is the cofactor of A12, and cofactor of A13 is 2, 1, 1, 3, the elements of the determinant, and cofactor of A21 is minus of, so minus 1, 2 and 3 minus 5, and cofactor A22 is 3, 2 and 1 minus 5. So the values of these determinants. Then we have the cofactor of A23 is minus of 3 minus 1 and 1 and 3, and the cofactor of 3, so A31 is equal to minus 1, 2 and 1 minus 1, and the cofactor of A32 is minus of 3, 2, 2 minus 1, and the cofactor of A33 equal to 3 minus 1 and 2, 1. So the values of these determinants will give you the cofactors of each of the elements of the matrix A. So therefore we have the cofactor as, so minus 2, 9 and 5 as the first row elements, 1 minus 17 minus 10 as the second row elements, and minus 1, 7, 5 as the third row elements. And the transpose of this, so here we have written it as T. So this signifies that the transpose of this matrix will be the adjoint matrix. So by converting the rows into corresponding columns, we get the transpose. So that we have, so minus 2, 1 and minus 1 in the first row, 9 minus 17 and 7 in the second row, and 5 and minus 10, 5 in the third row. So this is the adjoint A matrix. So now to find out A inverse, so A inverse is given by 1 by A determinant into adjoint A. So what is A determinant? So A determinant we have found out it as minus 5. So therefore this will be equal to, so 1 divided by minus 5 into the adjoint A matrix. So now we have the equation x equal to A inverse into B. So now we have to find out the matrix multiplication of A inverse and multiplied with the matrix B. So therefore we have, so writing down the given equation in the matrix form. So we have the given equation, so that is X is the matrix X, Y, Z equal to, so A inverse. So write down the A inverse matrix and write down the B matrix. So what we have written in the initially. So now we can perform the matrix multiplication between A inverse and B matrix. So by multiplying the corresponding row matrix, the row elements of the A inverse matrix, so with the corresponding the column elements of the B matrix. So therefore we have, so this is equal to, so minus 1 by 5 into, so minus 2 into 13 is minus 26, plus, so 1 into 3 is plus 3, and minus 1 into 8, so minus 1 into minus 8 is plus 8. So this is the element of the first row. So coming to the second row, we have 9 into 13 is 117, plus, so minus 17 into 3 is minus 51, plus, so 7 into minus 8 is minus 56. So these are the elements of the second row. And coming to the third row, we have 5 into 13 is 65, and minus 10 into 3 is minus 30, and 5 into minus 8 is minus 40. So this on simplification we have, so minus 1 by 5 into minus 15, 10 and minus 5. So this we can, so simplify this further and write this as 3 minus 2 and 1. So because, so we can multiply each element of the matrix with, so 1 by 5, so that we get the value, and taking out the negative sign we have 3 and minus 2 and 1 as a single column matrix. So in the LHS we have X, Y and Z. So now equating the corresponding elements, so we have, so X equal to 3 and Y equal to minus 2 and Z equal to 1. So therefore the corresponding values are X equal to 3, Y equal to minus 2 and Z equal to 1. So thus we have found out the solution, so using the matrix method. So this completes the solution. So for the question number 2. So now let us take up the question number 3. So this is also of the similar form. So we have the given equation, so X minus Y plus 2Z equal to 3, 2X plus Z equal to 1 and 3X plus 2Y plus Z equal to 4. So call this as the equation number 1, this as the equation number 2 and this as the equation number 3. So as I told you earlier, so take the coefficients of X, Y and Z from equations 1, 2 and 3 and form a matrix A. So therefore we have, so 1, minus 1 and 2 as the first row elements, and 2, 1, so 2, 0 and 1 as the second row element. So because in the second equation the Y coefficient is missing, so therefore Y is equal to 0. And in the third equation we have 3, 2 and 1. So these are the elements of the third row. And the matrix X, so containing elements of the variables, so that is X, Y and Z. And the matrix B, so containing the RHS term, so that is 3, 1 and 4. So thus we have written, so the matrix A, the matrix X and the matrix B. So now this is of the form AX equal to B, so that we can write this as X equal to A inverse of B in order to find out the values of X, Y and Z. So now we have to evaluate A inverse. So as I told you, to evaluate A inverse, so we have to evaluate A determinant and A adjoint of A. So now in order to find out A determinant, so let us try to find out A determinant. So working on the previous lines, how to find out the determinant value. So we can find out the value of A determinant as equal to 1 into 0 minus 2. So you can either expand along the row. So here, so expanding along the row we have, so 1 into 0 minus 2 and minus of minus 1 into 2 minus 3 plus 2 into 4 minus 0. So therefore we have 1 into minus 2 plus 1 into minus 1 plus 2 into 4. So this on simplification is equal to 5, so which is not equal to 0. So therefore the matrix A is a non-singular matrix and therefore A inverse exists. So now we have to find out adjoint A. So as I told you earlier, so first write down the cofactors of each of the elements of the the matrix A, and from that you can find out the transpose of this. So the transpose of this will be given the adjoint A matrix. So therefore, writing down the adjoint A matrix, so as shown here, so write down the cofactors of this so that we get -2, 1 and 4, 5, -5 and -5, and -1, 3 and 2 as the elements of the matrix, and the transpose of this. So you can change the rows into columns and columns into rows so that you get -2, 5 and -1 as the first row element, 1, -5 and 3 as the second row element, and 4, -5 and 2 as the third row element. So therefore A inverse is given by 1 by A determinant into adjoint A. So what is A determinant? A determinant equal to 5. So isn't it? So here we have evaluated. So what is A determinant? Equal to 5, isn't it? So therefore we can write this as 1 by 5 into the adjoint A matrix. So now the given equation is X equal to A inverse into B. So therefore write down the matrix A inverse and the B matrix, and then you can perform the matrix multiplication of A inverse and B. So therefore, this equation can be written in the matrix form as, write down the given equation in the matrix form, so that we have the matrix containing elements X, Y and Z. So that is equal to 1 by 5 into A inverse matrix and the B matrix. So this is the A inverse matrix and this is the B inverse, B matrix. So now performing the matrix multiplication between these two, we have -6 plus 5 minus 4 and 3 minus 5 plus 12 and 12 minus 15 plus 8. Or in other words, we have 1 by 5 into -5, 10 and 5. So that on further simplification we have 1 by 5 into -5 is -1, 1 by 5 into 10 is 2, and 1 by 5 into 5 is 1. So therefore we have equating the corresponding elements in the LHS and in the RHS matrix we have. So X equal to 1, -1, and Y equal to 2 and Z equal to 1. So thus we have found out the values of X, Y and Z. So that is X equal to -1, Y equal to 2 and Z equal to 1. So this completes the solution. So for the question number 3. So now, similarly on the same line, you can solve the question number 4 also. So we have in the question number 4 the given equation. So that is X plus Y plus Z equal to 5. So call this as the equation number 1. So then we have 2x plus y minus z equal to 2. So call this as the equation number 2. Then we have 2x minus y plus z equal to 2. So call this as the equation number 3. So now as I told you earlier, so the coefficients of x, y and z in the equations 1, 2 and 3 will be the corresponding row elements of the matrix A. So that you can write this as 1, 1 and 1. So because in the equation 1 we have the coefficients of x, y and z are 1, 1 and 1. So this forms the elements of the first row. So then in the equation 2 we have coefficients of x, y and z are 2, 1 and minus 1 respectively. So this forms the elements of the second row. And in the equation 3 we have the coefficients of x, y and z are 2, minus 1 and 1. So that these form the elements of the third row. So that we can write this as the matrix A, and 5, 2, 2 as the matrix B, and x, y, z as the matrix of the variables. So therefore we have, let A equal to the matrix what we have evaluated of the coefficients, and x be the matrix of the variables, and B be the values on the RHS. So now let this be of the form Ax equal to B, so that x equal to A inverse into B. So now we have to find out A inverse. So A inverse can be found out by finding out A determinant and then the adjoint of A. So finding out A determinant. So now expanding along the row 1 of the matrix A, we have 1 into 1 minus 1. So minus of 1 into 2 plus 2 plus 1 into minus 2 minus 2. So that will be equal to 0 minus 4 minus 4, and that is equal to minus 8. So this is not equal to 0. So therefore we can say that A is a non-singular matrix and A inverse exists. So now to find out the adjoint A. So in order to find out the adjoint A, we have to find out the cofactors of each of the elements of the matrix A. So this can be found out by, so the cofactors are written as shown here. So we have as discussed in the previous examples on the same matrix method. So we can write down the cofactors as shown here. So we have 1 minus 1 as the cofactor of A11. Cofactor A12 is minus of 2 plus 2, and cofactor of A13 is so minus 2 minus 2, and cofactor of A21 is minus of 1 plus 1, and cofactor of A22 is 1 minus 2, and the cofactor A23 is minus of minus 1 minus 2, and the cofactor of A31 is minus 1 minus 1, and the cofactor of A32 is minus of minus 1 minus 2, and the cofactor of A33 is 1 minus 2. So this on simplification we have the cofactor, so that we can write down the transpose of this will be the cofactor or the adjoint matrix. So that we have on simplification of this A11 equal to 0, A12 equal to minus 4, A13 equal to minus 4, and A21 equal to minus 2, and A22 equal to minus 1, and A23 equal to 3, and A31 equal to minus 2, and A32 equal to 3, and A33 equal to minus 1. So these are the cofactors. So the transpose of the cofactor matrix will be the adjoint A matrix. So therefore the transpose of this, so by changing the rows into the corresponding columns, so we get the adjoint A matrix. So that we have the adjoint A equal to the matrix containing elements 0, minus 1, minus 2 in the first row elements, minus 4, minus 1, 3 as the second row elements, and minus 4, 3 and minus 1 as the third row elements. So therefore A inverse is given by 1 by A determinant into adjoint A. So A determinant equal to minus 8, and therefore we can write this as equal to 1 divided by minus 8 into adjoint A matrix. So now the given equation is, so X equal to A inverse into B. So writing down this in the matrix form we have, so write down the X matrix. So that is we have, so minus of, so 1 by 8 into, so here you write down the A inverse matrix and then write down the B matrix. So on the LHS you have the X matrix. So now on simplifying this, so we can simplify by the matrix multiplication. So that is, so A inverse into B. So here, so you can evaluate, so A inverse into B, so by the matrix multiplication. So by matrix multiplication, so with the corresponding row elements of the A inverse matrix, so with the corresponding column elements of the matrix B elements, so that we can have, so 0 into 5 is 0, minus 2 into 2 is minus 4, and minus 2 into 2 is minus 4. So this will be the first row elements. So coming to the second row we have, so minus 4 into 5 is minus 20, and minus 1 into 2 is minus 2, plus 3 into 2 is 6. So this will be the second row element. And coming to the third row we have, so minus 4 into 5 is minus 20, plus 3 into 2 is 6, plus minus 1 into 2 is minus 2. So this on simplification we have, so minus 1 by 8 into, so minus 8, minus 16 and minus 16 as the elements of the matrix. So this on further simplification we have, so since 8 is a factor of all these three elements, so we have, so 1, 2 and 2, so that is we have, so 1 by 8 so here we have, so here we have, so minus of 1 by 8, So minus 4 equal to minus 8, and so minus 20 minus 2 plus 6 equal to minus 16, and minus 20 plus 6 minus 2 equal to minus 16. So therefore here, so since this so minus 1 by 8 acts as a scalar value, so and 8 is divisible or it is factor of all the elements of the matrix, of the resultant matrix, so that we have, so minus of, so 1 by 8 into minus 8 equal to 1, and minus of 1 by 8 into minus 16 equal to 2, and minus of, so 1 by 8 into minus 16 equal to 2. Or we can also so take the negative signs, and therefore we can have the values of x, y and z. So that is, we have, so comparing the corresponding values of x, y and z. So we have x equal to 1, y equal to 2 and z equal to 2. So these are the solutions of the given equation. So that is, we have x equal to 1, y is equal to 2 and z equal to 2. So this is the solution, and this is solved by the matrix method. So this completes the solution for the question number 4. So now let us take up the question number 5 and 6. So question number 5 and 6 also is solved by matrix method. So given the equation, so we have to solve by matrix method the question 5 and 6. And the question number 7 we have, so verify A into adjoint A equal to adjoint A into A, and that is equal to A determinant into I. So given the matrix A as shown here. So now let us take up, so all this is coming under the 5 marks category. So now let us take up the question number 5. So we have the given equations, 2x minus z equal to 0, so call this as the expression number 1. 5x plus y equal to 4, so call this as the equation number 2, and y plus 3z equal to 5, so call this as the equation number 3. So now, as I told you, so form a matrix, so which are the coefficients of the variables x, y and z. So in the equation 1 we have the coefficient of x is 2, the coefficient of y is 0, and the coefficient of z is minus 1. So therefore this forms the element. So 2, 0 and minus 1 forms the elements of the first row. And in the second equation we have 5x plus y equal to 4. So therefore the coefficient of x is 5, the coefficient of y is 1 and the coefficient of z is 0. So this forms the elements of the second row elements of the matrix A. And coming to the equation number 3, we have y plus 3z equal to 5. The coefficient of x is 0, the coefficient of y equal to 1 and the coefficient of z is equal to 3. So therefore let the matrix A be the coefficients of x, y and z. So this be the matrix A, and x be the coefficient of the matrix of the variables, so that is x, y and z, and B be the matrix of the terms in the RHS, so that is we have 0, 4 and 5. So now we have, so this is of the form Ax equal to B, so that we can write x equal to A inverse into B. So now to find out A inverse, so in order to find out A inverse, so we have to find out A determinant, and then we have to find out the adjoint of A. So now A determinant equal to, so now expanding along the row 1, so expanding along row 1 we have 2 into 3 minus 0, so minus of 1 into 5 minus 0, so that we have 6 minus 5 equal to 1, so which is not equal to 0. So therefore A is a non-singular matrix, and therefore A inverse exists. So from this we can find out the adjoint A. So as described earlier, so first you write down the cofactors of each of the elements of the matrix A. So once you find out the cofactors, so then the transpose of that, so that will be the adjoint, the matrix of the A. So therefore, so finding out the cofactors. So cofactor of A11 equal to 3 minus 0, cofactor of A12 equal to minus of 15 minus 0, cofactor of A13 equal to 5 minus 0, and cofactor of A21 equal to minus of 0 plus 1, and cofactor of A22 equal to 6 minus 0, and cofactor of A23 equal to minus of 2 minus 0, and cofactor of A31 equal to 0 plus 1, and cofactor of A32, so that is equal to minus of 0 plus 5, and cofactor of A33 equal to 2 minus 0. So therefore the transpose of this will be the adjoint matrix. So that is, we have 3, minus 15 and 5 as the first row elements, minus 1, 6 and minus 2 as the second row elements, 1, minus 5, 2 as the third row element. So the transpose of this. So by changing the row into corresponding columns, we have 3, minus 1, 1 in the first row, and minus 15, 6 and minus 5 in the second row, 5, minus 2 and 2 in the third row. So this forms the adjoint A matrix. So now we have to find out A inverse. So A inverse is given by 1 by determinant A into adjoint A. So what is A determinant value? Equal to 1. So therefore this will be equal to 1 divided by 1 into adjoint A matrix. So now we have evaluated A inverse. So after evaluating A inverse, so now substituting in the given equation, so that is x equal to A inverse into B. So writing down this in the matrix way, so write down the matrix X, so write down A inverse matrix, write down the B matrix, and then perform the matrix multiplication between A inverse and B matrix. So therefore we have the X matrix in the LHS equal to A inverse matrix and B matrix. So now by matrix multiplication of these two, we have 0 minus 4 plus 5, 0 plus 24 minus 25, and 0 minus 8 plus 10 as the first row, second row and third row elements, isn't it? So because we have 3 into 0 is 0, minus 1 into 4 is minus 4, plus 1 into 5 is plus 5. So this forms the elements of the first row. And coming to the second row, we have, so minus 15 into 0 is 0, plus 6 into 4 is 24, plus minus 5 into plus 5 is minus 25. So this forms the elements of the second row. And coming to the third row, we have 5 into 0 is 0, minus 2 into 4 is minus 8, plus 2 into 5 is plus 10. So that on simplification we get 5, so minus 4 is 1, then 24 minus 25 is minus 1, and minus 8 plus 10 equal to 2. So therefore comparing the corresponding elements, we have x equal to 1, y equal to minus 1, and z equal to 2. So this forms the solution for the given equations, and this is so done by the matrix method. So this is the solution for the question number 5.